Hi folks, and welcome back to Math with Captain Rod. I'm making this video here to help teach you how to solve exponential equations. So there's a bunch of examples we're going to look at, and before we start looking at these examples, first of all, I'd like to point out there's kind of like two ways you can solve these. There's what I call kind of a cutesy method, and then there's what I would call a brute force method. Cutesy methods are methods that kind of work some of the time for relatively simple problems, and brute force methods always work. So we're going to take a look at this first one here. This 4 to the x equals 64. And you'll notice that 64 is a multiple of 4. I believe it's, let's see, 4 squared is 16 times 4. So that's 4 to the third power. So this 4 to the x is equal to 4 to the third power. And now when we compare 4 to the x to 4 to the third, we see that x is equal to 3. That's what I mean by the cutesy method. Now that worked fine because 64 was was an easy multiple of 4. But had this been a different number like 67, that would not have worked. Now, here's what I would call the brute force method. All right, I'm going to rewrite that equation over to the right. And remember that logarithms have this beautiful property that if you take log of something to a power, I'm just going to put log of n to the p or whatever, it doesn't matter what it is, the power can be written out front. And that property is very, very useful for solving logarithmic or exponential equations. If we take the log of both sides, this is now going to read natural log 4 to the x equals natural log 64. Now, the first thing you might wonder is why natural log? Why not log base 10? And my answer to that is it doesn't matter. You can use either. You typically would use either natural log or log base 10 because your calculator has buttons to calculate values for either of those. I tend to use natural log simply because it's less writing than log. So now we can solve this, we can apply this beautiful property. X times natural log of 4 is equal to natural log 64. Now natural log of 64 and natural log of 4, these are just numbers. So this can be solved by dividing both sides by natural log of 4. So we have our solution for x. Natural log 64 over natural log 4. And I'm just going to leave that alone. I don't have a calculator on me or anything like that. All you're going to get are exact answers today, but I would consider this done. There's really no reason to do much more than this. Would have had virtually the same thing had we used log base 10. And that's what I mean by brute force. This method will pretty well always work. It's not dependent on the equation being one of these kind of nice, pretty looking ones. So I'll try to illustrate both methods where appropriate. So this next one here, oops. There we go. So this 3 to the 6x 3 to the 2x equals 81. Well, again, this one kind of smells like that cutesy method might work. If we combine these together, this would equal 3 to the 8x. Because remember, when you're multiplying, you add the powers. All right, now if we look at this thing on to the right, remember the 81 is 9 times 9. And 9 is 3 squared. So 81 can be written 3 to the 4th power. And now we have 3 to the 8x equals 3 to the 4th. So by direct comparison here, we can see that 8x is equal to 4, so x is equal to 4/8 or 1/2. And again, that's what I would call the cutesy method. Now, brute force method would look like this, and I'm going to pick up right here. If you take the natural log of both sides, this is going to read natural log of 3 to the 8x equals natural log of 81. Using that beautiful property here, this means, or can be written 8x times natural log 3 equals natural log 81. And you can divide out both the 8 and the natural log of 3. So x is going to equal natural log of 81 over 8 times natural log of 3. And again, if you like to write more, you can use log base 10 as well. And I would invite you to get your calculator out and give this a whirl, and you should get 0.5 out of that, because that's what we got over here. All right, moving on with the examples. So this one, 7 times e to the 2x equals 1099. So that one definitely is not going to be a cutesy one. What we want to do here is start by dividing the 7 out so that we have e to the 2x all by itself. Now, if I had a calculator, I might be tempted to write that as a decimal, but I'm just going to write it as is. Now, again, this can be, to get the 2x out of the power, we can take the logarithm of both sides. And I definitely would suggest using natural log. Interestingly enough, though, you don't have to. You can use log base 10 on this. It'll work out just fine. You'll see the difference here in just a moment. Again, applying that beautiful property here, this now can be written 2x natural log e equals natural log of 1099 over 7. Now the natural log of e is 1. And had we used base 10, we would have log base 10 here, but we would also have log base 10 on the other side. And you would just divide out the log base 10. It doesn't really matter. But since natural log of e is 1, we can then say, okay, x is equal to, now we're just dividing out the 2. Let's see, how about we write that 1/2 natural log of 1099 over 7. The only thing that would have happened had we chose to use base 10 is right here, this would read log base 10 of e, and you'd still have to divide that out, so that would be sitting over on the other side, but it's really no big deal. Generally speaking, though, if you see the natural exponential number, I would just use natural logs for sure. All right, so this guy, again, brute force is definitely the way to go. Natural log e to the x squared is equal to natural log of 39. Using that beautiful property, x squared times natural log of e is equal to natural log of 39. And again, natural log of e is 1. So x is going to be the square root of natural log of 39. Now, the natural log of 39, right, is some positive value. This thing is just fine. If we look at this right here, this equation actually has 2 solutions, because x could be a negative number and still solve this. So we're going to do the plus or minus on this to get both of them. And we're done. There's 2 solutions to that equation. All right, one more example, I believe, for exponentials, and call this video done. So this one, let's see, 3 times 7 to the 2x plus 1 equals 5. This thing definitely is not going to have a cutesy type of answer to it, so we're going to be using brute force. Definitely start by dividing both sides by 3. There's our new line. Then we want to get this thing out of the power, so we take the log of both sides. Again, you can use natural log or base 10. Applying that beautiful property. Now, natural log of 7 is just, some number, so I probably would start by dividing both sides by natural log of 7. Need a little room here, so then we're going to have 2x plus 1 is equal to natural log of 5/3 divided by natural log of 7. Subtract 1. Boy, can't believe I have to recopy all of that for that one little line. Divide both sides by 2. So x is going to equal, how about we write it like this, 1/2 times natural log of 5/3 over natural log 7 minus 1. This is a perfectly acceptable answer. I think I'll just leave it like that. So video's pushing 10 minutes here. That's about as long as I like to keep my videos. Hopefully after watching this, you have an idea of how to solve exponential equations, whether they are nice, pretty looking ones or not. Have a great day.